So now that we have two different methods for finding volume, we a lot of times get to make a decision about which one's going to be best. And given the problem, sometimes one's better than the other. When we're using the disk method, we are slicing perpendicular to the axis of revolution. Okay, so they're perpendicular slices. So if we were revolving this figure about this line, our disks are going to go this way. So if this is the axis of revolution, we slice this direction. If this is our axis of revolution, we slice in this direction. Okay, so it's perpendicular. So for this problem, your thickness would be dy, and for this one, your thickness would be dx. For the shell method, the shells are set up so they're parallel to the axis of revolution. So if you were revolving here, you would set up your shells to go this way. And then the thickness of the shell would be dx. And on this one, if you are revolving here, you would want to set up your shells to be parallel to that. So this one would be dy. So a lot of time it depends on the function. If it's already set up that you want to be able to use x's, dx, that's going to be how you pick the disk or the shell. Sometimes you just get a flat out choice because sometimes it doesn't really matter. Number 3 is a great example of that. We actually did this exact problem in 7.2 using the disk method and washer. So we want to find the volume of the solid formed by revolving the region bounded by the graph of y equals x squared plus 1. I already drew that parabola. Y equals 0, x equals 0, and x equals 1, which is right here. So this is the region that we're taking. And we're going to revolve it around the y-axis. Okay. So when we did this in 7.2, we used the disk method. So we have to slice perpendicular to our axis of rotation. And so we were slicing disks that looked like this. When we did this in 7.2, down here, these are disk method because those are solids. But then once you got up here, it was washer method because there's a hole in this one. And we decided that we would have to use two different integrals. And that's what we did in 7.2. You can go back and look at your notes for that. Is you had to set up this part from 0 to 1 using the disk method, and then this part from 1 to 2 using the washer method. Now, I want to show you, if I want to get rid of all of that pink stuff that I just drew. If we instead use the shell method, we don't have to split it up because to do shells, we do it so it's parallel. So our shells are going to go this way, and the thickness of our shells are dx. Okay, and we don't have to worry about splitting it up into disks and washers because the shell method can handle having a hole or not having a hole. Doesn't matter. So this one, probably better to do shell method. So we are going to do 2 pi, our radius in terms of x, and our height in terms of x, dx. All right, so when we do this, clearly we're going from 0 to 1 in the x direction. The radius of the cylinder is just x, and the height of that cylinder is determined by the function, which is x squared plus 1. And that's it. That's our setup. Now we just have to integrate and find our solution. So I'm going to go ahead and multiply by x. That gives us x cubed plus x. I'm going to take the antiderivative. So we have 1/4 x to the 4th plus 1/2 x squared. Come up here to keep working. So 2 pi, first I'm going to plug in 1. So that's going to give me 1/4 minus 1/2. Nope, not minus, plus. Minus, and then I'm going to plug in 0, which is going to be 0. Don't know what happened there. All right, so we get 2 pi times 3/4. So our final answer is going to be 6/4, which reduces to 3/2. So 3 pi over 2 is the volume. And if you check your answer from 7.2, I don't remember which example this was, but you did the same problem and you got the same answer. All right, number 4, a pontoon is to be made in the shape shown on page 461. I already kind of sketched it for you. Pontoons are like the things that make the boats float, pontoon boats. The pontoon is designed by rotating the graph of y equals 1 minus x squared from -4 to 4 about the x-axis. So that's kind of what that looks like. You're going to rotate it, and it's going to give you this torpedo-like shape. Just wanted to point out, this is the equation of an ellipse. Maybe you can't see it the way it's written now. We did ellipses last year, right? I believe so. Okay, so if I add that x term to both sides, I get x squared over 16 plus y equals 1. Okay, and that's pretty standard for our ellipse standard formula. Okay, so that's what we have here. All right. We want to find the volume of this. So we can use disk or shell method. If you were to set up your shells, the shells would need to be parallel to that axis, so like this. And then the thickness would be dy. So we would need to solve this for x, which doesn't sound great. So maybe instead, what would disk method look like for this? If we were doing disk method, we slice perpendicular, and so all of our disks, we're going to have various size disks, and they'll get smaller like this. The thickness of those are in the x direction, so this is dx. So I think I want to use that since this is already set up that we have a function of x. So for this one, let's use the disk method. All right, remember that disk method is pi and the integral of the function of the radius squared. We decided we were in dx. There's not a hole in this pontoon. That would be bad. So we don't have to worry about the washer method. So pi in the x direction, we are going from -4 to 4. It told us that in the problem. Our function is 1 minus x squared over 16 squared. And there it is. That's what we need to integrate. All right, so we're going from -4 to 4. We're going to have to FOIL this thing out, which is going to give us 1. And then we have minus x squared over 16 minus x squared over 16. So that's going to be minus 2x squared over 16, which is going to reduce to minus x squared over 8. And then plus, sorry about that, plus, let's see, x to the 4th over 256. Okay, those are not beautiful numbers, but we can do this. So antiderivative of 1 is just x minus, this is going to be x cubed, which means we'll need a 1/3, so that'll make that 1/24. Plus, we're going to have to bump this up to an x to the 5th, and we'll need a 1/5 in that. And I don't know, 1280, 1 over 1280. And we're evaluating from 4 to -4. And then we're going to plug in. I would definitely use your calculator for this. When I plugged in 4, I got 32/15. Except I can't write it down. You'll never know what the answer is. There, I don't know why that was so hard. Minus, when I plugged in -4, I got -32/15, all by the magic of a calculator. And so my final answer, it was 64 pi over 15, or if you did that as a decimal, I think it was 13.4 cubic feet for those pontoons. Okay. Now, again, if we had decided in example 4 that we were going to use the shell method, we could have done that. Let me erase all of that. Don't worry, I won't make you go through the whole problem. Okay, then our thickness is in terms of y. So when we plug this all in, we would have needed 2 pi, a function, our radius as a function of y, and our height as a function of y. So the radius of the cylinder is just determined by y. And I think we're from 0 to 1, which that looks a little bit easier. But then to get this in terms of y, we need to solve this for x. And it's totally doable. Let's see. X squared over 16 equals 1 minus y. I'm going to multiply by 16. And we'll take the square root of it. That's supposed to be y squared. Yeah, that's supposed to be a y squared. That's just a typo. It doesn't change the problem. All right, so we get this thing. A little harder to deal with. It's doable. It's a U substitution, and you can definitely get there, and you should get the same answer. But I just wanted to give you an example of one that was maybe easier using the disk method.